Hi there. In this section, I'm going to talk about section 13.8. 13.7 we're skipping. It involves some rather tricky graph stuff that is really not worth talking about now. We might circle back to it at the end of the year. But in section 13.8, we will be talking about reciprocal trigonometric functions. The idea here is we're already familiar with cosine and sine and now tangent. But there are examples of problems, especially word problems and applications, where it's actually more helpful to think about the reciprocals of these things, to kind of think of them upside down or backwards or reversed or in some way. So we have vocabulary and functions that simply name the reciprocal versions of these. So one of them is called secant, and cosine and secant are reciprocals. One of them is called cosecant, and sine and cosecant are reciprocals. And then the last one is called cotangent. So tangent and cotangent get paired up. That feels about right. There is something a little bit awkward that cosine, the one with a co, is paired up with secant without a co, and sine without a co is paired up with cosecant. You just need to memorize that this is how it works. So here it is written out again. Cosecant of theta, that's abbreviated CSC, is simply defined to be 1 divided by sine of theta. Secant of theta is defined to be 1 over cosine of theta. And tangent of theta is cosine of theta over sine of theta, which is kind of like taking 1 over tangent. Technically, they're not quite the same thing because of division by 0 issues. So I'll just say usually. Right? Every once in a while, if it seems like you're dividing by 0 or have 0, you want to use this as the actual definition. And because we're dividing, these are functions that are not defined everywhere. They do have things missing from their domain because we can't divide by 0. But the good news is that we really don't need to learn anything new except the definitions of these functions. So for example, if I want to compute cotangent of negative 5 pi over 6, I know by definition this is cosine of negative 5 pi over 6 over sine of negative 5 pi over 6. I can try imagining my unit circle. Negative 5 pi over 6 is a location like that. The cosine would be negative root 3 over 2. The sine would be negative 1/2. And this would reduce to root 3. So hit pause and try these other 4 that I have here. In each case, just identify how this is defined and then use cosine and sine values and simplify your fractions. Okay, I hope you have done that. So here, cosecant of pi over 6 is 1 over sine of pi over 6. Pi over 6 is like 30 degrees. Its sine is 1/2. 1 over 1/2 simplifies to 2. Cosecant of pi over 3 is 1 over sine of pi over 3. Sine of pi over 3 is root 3 over 2. So we remember that dividing by a fraction is like multiplying by its reciprocal. You can think of this as 1 over 1 if you like. So we have 2 over root 3. And then if we want to be really good and simplify, we have 2 root 3 over 3 as the most simplified version. Cotangent of negative 5 pi over 4 is defined to be cosine of negative 5 pi over 4 over sine of negative 5 pi over 4. Negative 5 pi over 4 is 1 1/4 pi backwards. It lands us here in the middle of the second quadrant. Cosine there is negative root 2 over 2. Sine there is root 2 over 2. And that just simplifies to negative 1 because we notice top and bottom are opposites of each other. And then secant of 3 pi is 1 over cosine of 3 pi. Cosine of 3 pi, 1, 2, 3 pi is this one here. So 1 over negative 1, which is negative 1. So I'll just point out in these examples that I cooked up somewhat randomly, we always got an answer, but I will just give you a warning. Sometimes secants cosecant, cotangent, and also tangent, we'll just do that as a reminder, are undefined. Computing these sometimes involves division by 0. But I'll point out that cosine and sine always have values. We're just finding a coordinate on the unit circle. There's no division involved. Now, just as a quick little application, here's a word problem where one of these reciprocal functions would be handy. And in this case, we'll just have the formula given to us. In the very near future, we will be able to deduce this formula on our own. So here's the idea behind this problem. We have a tower, like the Space Needle or the CN Tower or something like that, with an observation deck on the top. And someone up here in the observation deck is looking at an object down here. So here's the object. And as they look down, their line of sight, that's what I've put in the orange here, makes an angle of theta with the tower. And then D is this distance, and the height of the tower is 601 feet. So you can just take it as a given that this is how D and theta are related to each other. We'll explain that later on. But secant allows us to just have a formula for understanding the relationship between these two things. Obviously, this problem, that angle can change, this distance can change, depending upon which object is being looked at. Maybe there are a bunch of different objects down here. Depending upon where you look, the distance changes and the angle changes. So what is the distance if theta equals 40 degrees? So if theta equals 40 degrees, then the distance is 601 times secant of 40 degrees. You can do that directly in your calculator. Double check that you are in degree mode. And I can just type 601. If I go to my trig menu, secant is one of the choices, times 40 degrees. And this comes out to 784.550 feet. Now, what if and I've drawn an example that looks around 40 degrees. If that angle is more like 70 degrees, it'll be a bigger angle, and presumably it's a larger distance. Right? We're now imagining we're looking at something farther away that requires a bigger angle. So let's see if we get a bigger answer when we do 70 degrees. D is equal to 601 times secant of 70 degrees. Again, I can just type that into my calculator. 601. In the trig menu, secant is there for me to click on. 70 degrees. And this time I get 1757.206 feet. Right? So it's much bigger. It's in fact more than twice as big. These kind of word problems with triangles hiding in them, right? That's really what's going on here. We have this word problem and somehow there's a triangle lurking. You will soon get very good at doing these completely on your own. But here, it's just practice understanding that secant or tangent or cosine or one of these can be really helpful, and that your calculator can do most of the heavy lifting for you. All right, this was a quick section and we are done.